All right, let's talk about this one, ECB versus CBC modes, which is a very famous one that you often demonstrate with this image of tux. So I'm going to save this image. It's just a simple bitmap file. I think any version of cryptool might work, but if you're going to do the cryptool projects, they seem to have changed it so the steps are different. That's why I've been skipping over them. You can do them, but it'll be a little harder to find your way through the tool now than it used to be. Anyway, so I'm going to save this image in the folder I'm using, which is VP. All right. And so that's tux.bmp, I think. All right, let's take a look and see if I've got it. Get out of here with Control D, Control C, Control D. All right, now LS, and I have tux.bmp. Okay, that's what I wanted. Now, this is something I learned from CryptoHack, which I mentioned, which is very nice, is to use this library, PyCryptodome. There are some older Python libraries, but this one is the newest one that has all the latest versions of everything, and it's really very nice. So PyCryptodome is there, and I think requirement is already satisfied. Okay, I've already done it as machine. So now we can use Python 3 in interactive mode for this stuff. That's pretty simple. Okay, this is how you do AES, the official approved advanced encryption system that we're all using. So this imports from CryptoCipher the AES library, and this defines a key. You need a 16-byte key, and I'm just using this, not that this is a secure choice. It's just any old key so I can see encryption. And now I'm going to create a new AES object with the key and using ECB mode. Now, ECB mode is also called textbook mode. This is where every block of 16 bytes is encrypted independently. So if that's it. The simplest encryption mode, you take the data that comes in and every 16 bytes is independently encrypted with the key, and that's it. So when you do that, we can read the binary file. This is going to read that file into data called clear. We've done this before. This is going to open the tux file, read binary as F, and it's going to read the whole thing and put it in a variable called clear. Okay, press enter twice, and that does it. Now we're going to encrypt the data in clear. Now, this cipher object was defined up here as being this AES object. So if you did a directory of cipher, for example, it would show you that it has various methods, and one of them is decrypt and one of them is encrypt, because that cipher object knows the key. So I can do an encryption this way. I can create ciphertext by encrypting the clear. Now I get an error because the length has to be integral multiples of 16. And if I do length of ciphertext, cipher, okay. Clear is what I have, pardon me, clear. Okay, length of clear is this funny number. And if I do that modulus 16, it's got 2 bytes left over. And in electronic codebook mode, it's not kidding. You have to give it a block of text to encrypt. You can't give it less than a full block. It doesn't have any way of padding it or dealing with a short block. So you can't encrypt it all. In addition, I would like to encrypt this image and view the visible image. And the header of the image in the first 48 bytes or so has information like what type of file it is and how wide it is and how high it is. And I'd rather not encrypt that data. So what I'm going to do is I'm going to trim it. What this is going to do, using the same kind of string segments that we used before, this is going to make something called clear trimmed, which is going to skip the first 64 bytes and the last 2 bytes. So it'll contain most of the data in the image, but not the header and not the last 2 bytes. And now if I do the length of that, it's that number. And if I take it modulus 16, it's 0. So I could encrypt most of the file, except 64 bytes at the start and 2 bytes at the end, by just encrypting the clear part. So that's what I'm going to do, encrypting this trim part. So now I have ciphertext, and now I can build a new image containing the original unencrypted header, encrypted middle, and 2 bytes unencrypted at the end. So most of what I can see will be encrypted. And that's what I have here. The first 64 bytes of the clear text, then the ciphertext, then the last 2 bytes of the clear text. That'll be a visible image where the body of it is encrypted. And now I can open it with write mode and write out that ciphertext, just like we did before. So that creates another file, tuxecb.bitmap. Now I can just open that file in the viewer. So I go here to Documents, my home folder, and the folder I'm working in, which is this one. Okay. And so there's tux ECB. Okay, here's the original tux.bitmap. In fact, let me make this bigger. All right, here's the original tux.bitmap. And here's the encrypted image. And this is the famous demonstration. You may very well have seen it before. The problem here is if I have a region here that's all white, I'm just getting blocks that are all white, then another block that's all white, then another block that's all white. So it encrypts to something, but it's always the same. So the encrypted image still contains most of the information in the original image. My audio cuts off. That's not good. Is it okay? Can you hear me now? That's disturbing. I'm not doing anything. It should take a lot of processing. Let me know. Can you hear me on chat? Maybe not.
I can hear you.
You can hear me, but you're on Zoom.
I can hear you.
Can people hear me on Twitch? Maybe we need to switch to Zoom. Yes, but at times it cuts off. Okay. Well, all right. Shamsi, do you want me to switch the main front computer to Zoom? Would that be better? Okay. Can somebody do that? Just go to the front computer and either close or mute Twitch and just join Zoom up there. That'll be fine. It won't affect my recordings. I'm just recording this all in Zoom. In fact, I would pause it if I could. In fact, I think I can. Yeah. All right. Good. All right. So here you go. This is the problem. You encrypt it in electronic codebook mode, and you do not accomplish the goal of encryption. You haven't concealed the image. If there's blocks of repeated plain text, you get blocks of repeated ciphertext. So to fix that, you use electronic codebook mode. And that's what we're going to do down here. So in electronic codebook mode, you have to add an initialization vector. So again, I'm just going to use an arbitrary 16-bit value, 0, 1, 2, and 3, like that. Now I create a new AES object with cipher block chaining mode and IV. And in cipher block chaining, it's going to use this IV to XOR with the data before encrypting the first block. And then it's going to use the output of the first block as the IV for the next block. So it's going to use the encryption from one block to add a sort of random amount to the next block. And that will improve things. Now I just have to encrypt this stuff again in that mode, which is just repeating the same command because I've redefined cipher to use the different mode. And now I just build the object again with the encrypted inside and the unencrypted start and finish. And I write it this time to tuxcbc.bitmap. So now if I go to my files, here's tux CBC. And see, that's what you want encryption to do. It's just all random snow. There's nothing left of the pattern. So this is why cipher block chaining was much better than electronic codebook and was used for a while. Now there's Galois counter mode, Galois counter mode, I think it's French, which is considered even better. But they both have this property of really scrambling the data. All right. And there are some flags to find in there. So that's a good thing to try. If you haven't done that before, it's a good little exercise in Python. And it also shows you an important fact about these modes of encryption. So that's it for this one.